All these examples work every single time, but we can't really explain why they work. It's just something that we know. It's something we do. Similar to that color blue. At some point in your life, someone held up that color and said, what color is this? And you learned it was blue. We don't have that exact reasoning why it's blue. We just know it's blue. All right, so first off, we're going to describe what a postulate is. So if you need to turn your book sideways to write the definition, I'm going to write my definition in this margin, and I have a lot of space. But if you need to turn your book sideways and write sideways, you can. All right, postulate are things we know are true things we know are true but can't prove. Which is silly that that's kind of what we're starting off with today, because this whole chapter is about proofs. It's about proving things. And so today we're going to be talking about things that we can't prove. So these are just our accepted facts. All right? There are, how many postulates do we have on that list? 7. Okay. And as we go throughout them, these are just numbered based on what we have. It depends on your books. So if you go around and you're like, well, postulate number 2. It's not like Newton's law, where Newton's laws are always 1, 2, and 3, right? These ones are we just numbered them so it's easier for us to talk about them. They're not like officially numbered this way. All right, so to start off with, we have postulate 1, which is through any 2 points, there is exactly one line. So again, I'm going to use a highlighter today and one colored pencil. What are some important parts of this postulate when we read that sentence? Through any 2 points, there's exactly one line. What are we starting with? We're starting with how many points? 2. This one we're starting with 2 points. And when we have 2 points, that means that there is exactly one line. And if you even want to underline that exactly one or just one, that's kind of the important part here, is that there's just one line that connects them. So we can pick any 2 points. And between any 2 points, there's always going to be one. Can there be more than one? If I say exactly one, can there be more than one? No, just one. But there's always one. So if you think about this like with string, if we connect points, let's think about people as points here. Okay? If Ishmael and I are points, ready? How many ways can we connect each other with this string? One way. There's only this one path. Okay? Even if I go past Ishmael and I go to Naomi, ready? You might want to duck a little bit. There you go. Even though we got some people in between, there's still only one line. Now, Naomi, if you stand up, thank you. And we put this above our heads, is it still the same line as this line down here? Yeah, remember a line doesn't have that depth. So this line down here is the same line as up here. So anytime we have 2 points, there's always, sorry, I was trying really hard not to do that, thank you. Anytime we have 2 points, there's always one line that connects them that's a straight line. Okay, we could draw a lot of curves, loop-de-loops, things like that, but there's always just one straight line that connects those. All right, so I like to think about this as like a connect the dots, like a dot to dot. How many of you have done a dot to dot before? Like on a kids menu, right? They're everywhere. If this wasn't true, our dot to dot pictures would be all over the place. We wouldn't be able to say, oh, look, it's a dog, right? We'd be like, oh, yours turned out to be a dog, but mine's a flower. That's not how dot to dots work. They're all supposed to turn out to be the same ending drawing, okay? So my additional information, I'm going to just show a little bit what that is. I'm going to think about it as it's a dot to dot. That's my connection with this one, because I really like dot to dots. I buy the books that are like 1,000 dot to dots. Okay. And when we do dot to dots and we number them, so we have 1 point that's like 1, and we draw a line to 2, and then draw a line to 3. As we connect those dots, there should only be one way to connect them. All right, how are we doing? Making sense? Kind of? A little bit? Today's a weird, like, conceptual day of, like, it makes sense, but we don't know why it makes sense, and that's the whole point of postulates. We can show why it makes sense, but we can't, like, talk more about it. It's a little goofy. All right. Number 2, through any 3 non-collinear points, there's exactly one plane. Through any 3 non-collinear points, there's exactly one plane. All right, so if I talk about this as through any 3 non-collinear points, so how many points are we starting with? We're starting with 3, and they're non-collinear. Does anyone remember what does non-collinear mean? It has 2 prefixes there. Good, they're not together. Good. Non means not, co means together. So let's write that really quick off to the side in our additional information. When we say non-collinear, that means that we have 3 points not on the same line. Bless you. So if that non-collinear is goofing you up, non-collinear means 3 points not on the same line. Okay. All right, and when we have 3 points that are not on the same line, how many planes do we have? Exactly 1. Okay, and again, today's a lot about showing that it works. It's not a lot about like why it works, but it's a lot about showing. So, I'm going to ask, really put up 2 fingers over here, there, 2 fingers, and then put up 1 finger over here, camera, closer. There we go. So we have 3 points. Hold them up higher so people can see them. Thank you. We have 3 points here. Can I set this plane, this flat surface, down so it's touching all 3 fingers? Yeah, right? Like that. Okay, move your fingers differently. Move one up, down, sideways, further away. Yeah, and then one more. Gotta have 3. Okay, can I now, Cameron moved his finger so it's going this way. Can I now connect them still? Yeah, I can. A little bit. Hands a little bit away. So our plane can tilt. And because our plane can tilt, no matter what 3 fingers we use, it's going to work. Okay? Let's do it over here. Jada, Olivia, can you put up your fingers real quick? Closer. There you go. You want it to be like that? See? It works. Amazing. Ready? 3 fingers. Yeah, all of you, 1 finger up. Put it any way you want. Finger up. Okay, so there we go. It's touching all 3 fingers. Right? Okay, it doesn't matter how. I'm not telling you to put your fingers in certain places. We're just putting your fingers up, and it's touching all 3. So that's kind of our big idea here, is that a plane can tilt to touch the points. So if you have room to put that in there, you can put that in there. The plane can tilt to touch the points. And that's how that works. It doesn't have to just be flat. It doesn't have to be horizontal. We can tilt it so it's a vertical plane, so it's on its side, so it's going different ways. But it can tilt to make that work. All right, everyone grab a whiteboard. And a whiteboard marker. All right, on your whiteboard, you are going to draw a straight line. Your best you can, straight line. It can be as long as you want. It can go in any direction you want. Draw a straight line. So everyone draw a line on your whiteboard. However you want to draw it, but it's a straight line. As straight as you can make it anyways. It doesn't have to be perfect. Alright, now on your line, so put arrows on both ends because it's going to keep going on and on and on. Right? Got a line. Line goes on forever and ever and ever and ever and always and forever and ever and ever. Alright, now on your line, you're going to put 2 points on it. So put 2 points on your line. Well, wrapped around. Draw another line next to it that's shorter. I'm seeing a lot of people drew really long lines, which is great. Put 2 points on that line. Does it still work? Yeah, still works. So no matter what your line was, wherever it was at, how slanted it was, we can always put how many points on it? 2. So even if I drew one like this small, could I still get 2 points on that line? Yeah. I could put one here, and what do I know about a line though? It keeps going, so even though I only see one here, I can put another one a little bit further away. It keeps going. Good. So this time, this one looks really similar to postulate number 1, but postulate number 3 is a little different. This time we're starting with a line. So we're starting with a line, and the line contains at least 2 points. Okay, so we have that word contain. What does it mean to contain something? If a line contains points. It's a weird word to say 7 times in a row. Contain? Half. Mm-hmm. Half. Good. So a line has, and then it at least 2 points. So at least, what does at least tell us with at least 2 points? It's the minimum, the least amount. So 2 points, could it have more? Yeah, it can have 3, it could have 4, but the smallest amount is 2. Could a line only have 1 point? No, because that's our definition of a line. A line connects points. Okay, so this one's a little goofy because it's a little different than number 1. If we go back to 1, number 1 said through any 2 points, there's exactly 1 line. So number 1, what did we start with? The points, and then we drew the line. And number 3, it's like the converse. It's like it's flipped. We're starting with a line, and then we're drawing the dots. Good. So I'm just going to put that in my notes, that's what our difference is. Okay, and this one we're starting with the line. Okay, start with a line, and then we're going to get 2 or more points. 2 or more points. That's our definition of a line. A line means that's connecting points. So we should have 2 or more points. All right, I'm going to pass out paper. At your table, you're going to take some of the paper. So you're going to rip this paper so everyone gets a little piece. It's your choice how big of a piece you want. So figure out how you want to split that up between your groups. You could have the tiniest little piece. You could split it into equal parts. But go ahead and rip it. Just rip it. Doesn't have to be perfect. Everyone just needs a piece. Nothing crazy.
Look how much.
Yeah.
Look how much it was.
Yeah, well, because it's stripping it into equal pieces. Oh, that's fine. That's perfect. All right, rip off as much as you want. It can be the smallest piece. It can be a really big piece. All right, if you look around the room, does everyone have the exact same size pieces? No. Perfect. Love that. All right, but we're all starting off with a flat surface. We're all starting off with a piece of paper. On your piece of paper, you're going to put 3 points on it. On one side. Put 3 points on it. So 3 dots. Don't rip it. You can rip it. There you go. Just rip it. 3 points. Now, if you put your 3 points on a straight line, try to get 1 more point on there so it's not on the line. That's our goal. Was everyone able to do it? Anyone not able to get 3 points? Good. So even if you had a big paper, if we had a big paper like this one, 3 points. Good. Camille was a little silly. She used a teeny tiny one. And Camille was still able to get 3 points on it, even on a small one. So no matter what, when we start with a plane and we have points on it, we can always get 3 points. And remember, a plane, technically, again, it's like that line. It's supposed to keep going on and on. It's hard for us to imagine that because planes for us don't generally do that. So that's our number 4. A plane contains at least 3 non-collinear points. Okay, so a plane, again, we have that word contains. Contains means what again? Has, yep. A plane contains at least 3 non-collinear points. If you want to do that, like non-collinear points. You can change that word up if you want, or you can just highlight it. If you're like, I know what non-collinear means. All right, for my little additional information here, I'm going to remind us that we had different sized papers. So we all got different sized papers. But no matter our size of the paper, what were we able to do? We could do 3 or, what does that at least tell us? 3 or more points. All right, again, number 4 is really similar to which number? 2. The pictures look almost identical. In fact, I think I just copied and pasted this ending picture. Okay, but how does the beginning picture, how does that change? What are we starting with? Yeah, the number 4, we're starting with the plane, we're starting with a piece of paper, then we're drawing dots. Where in number 2, we would start with the dots, and then we're capturing those dots into a piece of paper. All right, on your purple piece of paper, you should have your purple piece of paper. Everyone have the purple piece of paper? Connect 2 of those dots with a line. Try to do as straight as you can. You can use the side of a whiteboard. You're going to connect 2 of those dots with a straight line. Or 3 dots, that's fine too. So connect 2 of those dots. So connect 2 of your dots. You have dots? Put 2 dots on there. Flip it out. Point. Beautiful. Amazing. All right. When you drew your point, your line, did you need another piece of paper to draw your line? Okay. If I take your piece of paper, I'm going to take Elena's. Does she still have her line now? No, because I took the plane that had the points, right? And because this plane had the points, where is the line now? Still on the paper. Amazing how that works, right? Okay. So, kind of goofy, I know that, again, this feels a little silly, but when we draw a line on a piece of paper through points, does that line get separated from the paper? No, it's just on the paper. So again, this is something that you guys are probably like, Miss Morrell's lost it. Duh, this is obvious stuff. We just need to state it. That way we know it's obvious stuff. All right, so that brings us to number 5. If 2 points lie in a plane. So 2 points. I'm going to circle that word lie, because that's a little different than our other word we've been using. If 2 points lie in a plane. So in this situation, what do we mean by that word lie? That they're not telling the truth, they're lying, staying points, cheating on all their tests. All right, 2 points lie. What does it mean to lie in a plane? Yeah, just be on it, right? Be in it. Okay, like you're lying in bed. That's what we're talking about with this kind of lie. Okay, you're in the plane, then the entire line containing those points lies in that plane. Just kind of highlighted everything there. I wasn't not supposed to, but that's okay. All right, so when we had that plane, we started with that piece of paper with those 2 dots, and you drew a line. That line connecting those 2 dots or those 2 points, the line was on the paper.
Can I go get a drink of water?
Why?
Because I'm thirsty.
No, we're in the middle of those. Got 3 more. You can do it. All right. So as we do this, we can't be. And we're going to go through some of our prepositions. You guys know your prepositions? Okay, it can't be above the paper when we draw that line. It's not going to be below the paper. It's not all of a sudden under the piece of paper. It's not going through the paper. What does that word through mean again? Or sorry, our word that we use for through is intersect. I was thinking backwards. I was thinking, what does intersect mean? Intersect means it's through. So it's not going through the paper. It has to be on the paper. So our key word there, our preposition, is that word on. It's on the paper. It's not above it. It's not below it. It's not through it. It's on that paper. When we move that paper, the line moves with the paper. All right, how are we feeling? Making sense? Got 2 more? I know it's not a great day. All right, Harper, will you grab this in? Thank you. Right here, will you grab this in? Thank you. Amazing. Can I usually grab this in? Thank you. All right, if we have two lines, that cross an intersection, how many places do they cross? Yeah, one place. Okay, even if we move over here, if I get closer to Harper, they're really, really close, how many times does it cross? One. Okay. No matter what, when you cross these lines, they're always going to cross once. Okay? It's kind of like two roads intersecting. Sorry. Alright, if we have two straight roads intersecting, what do we know about those roads? How many times would they cross? One time, yeah. Alright, so if I have two lines intersecting, what's the most amount that two straight lines can touch? How many times? Once. Okay, do two lines have to touch? No, what do we call two lines that don't touch? Parallel, and we're actually going to learn another word eventually called skew. Today, it's not the day for that. But two lines don't have to touch, but if they touch, they intersect. So two lines touch, they intersect. Then that intersection is where they touch creates exactly 1 point. Okay, two lines are crossing. Where they cross is exactly 1 point. So let's just talk about that word intersect for a second. Again, what does that word intersect mean? Crossing or touching. So if you want to say crossing, you could. I'm going to say touching. That's just the way my brain works. But they touch in only one place. Alright, this next one's a little goofy, so it's a little challenging to see when we're doing the whole thing. Dear, pass me a second. Just kidding, I'll do it now because I'm right here. So smart. Okay, it's a little hard to visually see when we're dealing with pieces of paper. We'll talk about it in the real world and our 3D world in just a second. Okay, but if I have two planes that intersect, so now I'm talking about these two lovely planes, and they're intersecting, they're going through each other. So everyone sees how these planes are intersecting each other? We still have one going this way, it's supposed to be straight, and then one going this way. Okay, the place where they intersect, I should probably hold that white piece of paper. Yeah, just hold that one like that. Where they intersect down that middle, they're touching in a lot of places. Are they touching only in one place? No, technically if they're going through it, it should be touching in every single spot. So what does it create if it's touching in a spot going up and down every spot? It creates a line, right? Okay, hold that for me. Thank you. Sorry. Not prepared. So many things here. Okay, if I take my string, my line, and I line it up there, it should touch every point where they touch. Okay, every point where they touch, if you can see that. Does that make sense? Okay, now in the real world, what we call that, where do we see two planes intersecting here? In the real world, where do we have two flat surfaces coming together? If we talk about the ceiling, what does the ceiling hit eventually in the back here? The wall. So where the ceiling hits the wall, we have a seam. Okay, it's right where they touch. That creates a line going across. Okay, same thing as when we have two walls touching. This room's kind of weird with our walls. As we have two walls hitting a corner, that corner is a straight line, right? We don't have those curves. Some rooms have curves, but this one doesn't. They come together at those points. Okay, so think about those edges. that are created. So last one, number 7, if two planes intersect. So two planes intersect. So two planes are touching. Then that intersection where they touch, they're not only going to touch in one point, they're touching in a whole line. The intersection is a whole line. So as we look at that intersection, this one's a little bit hard to see. I know it printed better this year than it did last year. But we have kind of this gray plane going and then this white plane. And it's like they're touching through the middle. They're creating that intersection. And when they create that intersection, they're touching in all these places. They touch in multiple places. So all the points where they touch form a line. And a space there. All the places where they touch form a line. They touch in multiple places. Think about where the ceiling touches the wall. It doesn't just touch the wall in one place and then they're disconnected. Okay, they're touching all those places.